Okay, the session is just started to being recorded. Welcome everybody. It's Vlado Zettel from GRC. I hope you will enjoy the session and yeah, nothing further from me at this moment. I will just give the floor to Dean. Dean, the floor is yours.
Okay, good morning, everybody. My name is Dean Hintz, and I'm joined by Christian Dahman and Soren Dubke from Contera, and also Trent also from Safe Software. So welcome. Glad that all of you could join us today. Thank you for taking the time to spend some time with us. And we're going to talk about implementing practical web applications on Inspire and real-time service infrastructure using the FME integration platform. And so I realized that there was a bit of, we shifted gears here to make this available online, but I do appreciate the whole team at JRC and, Lado and everybody that has helped host this. So thanks for attending. So, Trent, if you could run the first poll, I thought we would just check quick and see where everybody is from. And I think I can watch that. Here, I'll see if I see the responses there. Yeah, so if you could just type in the country you're from. Don't expect Canada will be the top winner here, but we'll see what happens. Looks like we got a few from Germany. Oh, that's a pretty good representation. At least a dozen countries there. There, thank you. So, jumping right in, so that's what we look like, and I'll probably shut off my camera in a second here, but let me just give you a quick overview of what we're going to talk about today. And oh, somebody chatted that they're here from Ivory Coast, so yeah, it certainly makes it easier to attend Inspire when it's online. So we're going to start off by looking at some FME work. And then we'll move on to some highlights of what's new. I think we'll have a little time at that point for Q&A for just any questions that might have come up from the first half, and then we'll get into the exercises from the workshop. So there is a link in the chat for starting up an instance, and there's also the cloud demo you can look at in parallel with what I'm doing. So in terms of where we are with Inspire, we all are fairly familiar with what Inspire is, but in terms of where or when, the deadline is fast approaching, in 2021. And so a lot of the infrastructure is already there. There's lots of data portals and OGC services available, but the real challenge is how aware is management of these resources? How developer and friendly is it, or how accessible is it for the public to use, and how easy is it for these to be updated? So I think I might stop the video for now. Okay, so we'll go ahead in a second and we'll run that poll, the second poll, Trent. So just a quick overview of what FME is, stands for Feature Manipulation Engine. And we created FME so that you could get the most value out of your data as possible and make data integration easy. So another way of looking at it, sometimes called spatial ETL, extract, transform, load, we allow you to rapidly prototype data integration models and automate them, provide them as services. And also, FME is a great integration or enterprise platform because it allows you to integrate across the different application silos you might have. So let's just switch to the view of that poll. Okay. Looks like we've got a pretty wide range there in terms of people that are new and intermediate advanced users, or people who've been using it for quite some time. So I'll try to make sure we have something for everyone. Some new stuff for those of you who have been using FME for a while, and also overview things, introductory points for those of you who might be new to FME. Yeah, so we basically allow you to connect to your data, transform it to meet your requirements, and then once you have a workflow, automate it and make that workflow available across the enterprise to people who may not even know they're running FME. We have the desktop and server cloud platform. So desktop is essentially the authoring environment, and then you can push a button, publish that to server, and server is also available either on-premise or in the cloud. And connecting to all types of data. We kind of got started with CAD to GIS, and then over time added support for raster databases, XML, GML, and you can see the progression over time. So now a lot of it's about connecting to IoT and web services, BI, you name it. So there's quite a range of data that FME lets you get access to. And a lot of it is also web connections. So connecting to APIs and whether it's Salesforce or Google Sheets, Tableau. So there's lots of APIs that you can connect to. So it's not just about file formats anymore. We also see ourselves as somewhat of a bridge between the open source, open standards environments and the proprietary world. There sometimes can be a bit of a gap there. And we allow you to build systems that are a blend of those. So now we'll look at how does FME, we're talking about FME, how is that relevant to your work in Inspire? So just a quick overview. You can think of Inspire support as and tasks as a bit of a life cycle. In order to generate Inspire data, you have to assemble a variety of data sets from different formats, transform them to meet the Inspire requirements, publish the Inspire GML, validate it, and then make that available as web services. And that's sort of a cycle. It can keep repeating as you update. And so maybe, Trent, if you could just run that poll, be curious to find out what type of Inspire workflows are you most commonly interacting with? Go ahead and have a look at that. So I guess maybe we're the ones observing Inspire from afar, being presenting here from Canada. Yeah, okay, that's a pretty good mix. It always seems like A and B are more popular choices than the ones further down the list, but coincidence. All right, thank you, everybody. Well, certainly over time, we have seen, like early on, there was the requirement to publish Inspire data, and so that's a lot of the energy and effort was around generating the GML, and now we're seeing a lot more systems that need to consume Inspire data, and that's certainly one of the objectives of today's demo exercise. So you could look at FME Data Inspector as a Inspire Explorer because it allows you to consume and interact with any of the Inspire themes, whether that's GML or raster data, point cloud, and other data feeds. So just a few words about some of the core Inspire challenges and workflows. So one of the main challenges is really this kind of orthogonal, I don't know, it's a bit of a difficult connect between the relational world of GIS and the object-oriented or nested data structures that we see with Inspire, particularly Inspire GML. So that can make things a bit difficult. There's a lot of joins required from diverse data sets to populate the complex data model. There's also, it's not just the attribute structure that's nested, but also the geometries can be fairly complex. And you can have multiple geometries and one-to-many relationships or lists. So that can all be a challenge to support. And so in terms of FME support, we have an application schema-based reader and writer for our Inspire GML. And we use parent-child IDs to do the nesting, support all of the annexes and all of the various geometry types required, including things like raster and point clouds. The bottom line is you don't really need to be an XML expert anymore to generate Inspire data, although you do need to know your data and the Inspire requirements. So just a few of the typical workflows involved. Schema mapping, so for your attribute data, tabular data, you have feature type mapping, attribute name and value mapping. And we have tools like Schema Mapper, which allow you to define crosswalk tables that can map from your source data set to Inspire. I'll just mention briefly, as Soren will go into more detail, but the Inspire Solution Pack, what that does is it packages up our black boxes, a certain amount of that. So you basically point at you dial in your fields and the data that's coming in, and it worries about a lot of the more complex data structures and setting defaults and whatnot. And Soren will show that in a minute. So this is just a quick footnote. We can see this quite a bit in support where people might complain that they're writing to GML and their geometry disappears. And so the one thing, because there are multiple geometries possible in Inspire and different geometry names, you actually have to use a geometry property setter to set the geometry name. If you don't do that, often the geometry will be dropped. So it's just a quick reference footnote there. And I don't have time to go through this in great detail, but this is just a quick example that you can play with and download from our knowledge base. And this just shows importing Inspire themes and selecting the feature types you want to write to, highlighting here's a geometry or bounded by. So those are sort of the XML underscore geometry dictate which properties hold the geometry, and that's the name to use when we use this name setter. And so this is what the workspace looks like. And this pattern is fairly common throughout using FME to publish Inspire data. But typically we read source data sets. There's often more than one. This is just a fairly simple example. Reproject ETRF 89, so the required Inspire coordinate system, create the required unique IDs and Inspire attributes, set that geometry name to match what's in XML geometry, and then write out GML. I have an extra writer I dropped in here, which shows how easy it is to write the GeoJSON. So if we do get into alternate encodings, I don't know how much time we have. We have to wait to the Q&A. If I have time later, I can show you an example of that using this particular workspace. But yeah, so we can publish to Inspire GML or other encodings as is needed. And that's the link to Maybe Trent, I don't know if you could paste that in the chat if anybody wants to try that out. So things to think about when writing: unique IDs, parent-child relationships, code lists, and required fields. The key here is iteratively test validation on a few feature types or a few features. Don't try to transform everything at once. The error messages are quite detailed, but if you try to do a whole data set at once, you might get swamped with errors initially. So some of the challenges are just finding the data. So this is more around switching gears and looking at how do we consume Inspire data. First, you have to find it. And in many cases, again, given the fairly rich data structure for Inspire, often for using it within GIS, we have to do a lot of simplification. So whether that be schema or geometry. And we've got a bunch of references for troubleshooting how to consume that. So this is just some schema simplification, reducing the number of fields. And in some cases, we want to select the first element because it's a lot of Inspire properties are defined as one or more, and that shows up as a list. So yeah, we often want to simplify the names. And here's some of the transformers you can use to work with renaming or work with lists. And geometry simplification. So there's a lot of tools in FME to do things like generalizing, simplifying the geometry, building paths, taking maybe an aggregator, so taking multiple edges and making them into single features, and even validating and repairing geometry. So maybe just to, I won't get into too much detail on troubleshooting. We can talk about that during the Q&A. This was a nice little tidbit if you're, I only figured this out fairly recently, but if you're in trying to troubleshoot a WFS post from the data inspector or from Workbench, you have to be in debug mode to actually see the contents of the post. Just a little tidbit there. So yeah, Trent, if you could run the Slido on the challenges. I think that might be one of our last polls. So what do you find most challenging about Inspire? Is it implementation, validation, just managing the data, or supporting clients? Well, actually, it looks like compliance and validation is certainly up there. I realize now that the order changes. It's not coincidence that the first two are the most popular answers. Okay, good. So still a lot of focus on implementation and compliance. And our example focuses a bit more on integration, but certainly implementation is part of it. Okay, so thanks for your responses there. So I will switch it over to Soren, and he's going to tell us a little bit more about the Inspire Solution Pack.
Yes, thank you, Dean. Good afternoon, everyone. I think you should be seeing my screen now. So yeah, as Dean mentioned, the Inspire Solution Pack is a plugin that we built for FME to make the data integration process easier. So what we basically did is we put some of the workflows that we saw that we use all the time when we did Inspire projects into the Workbench. So this are, for example, things like transformers that help you to build the identifiers or to do things that are there on almost all of the Inspire features, like the lifespan or validity attributes, and of course those code list attributes that you have with almost every Inspire theme, so that you have most of the information directly in the Workbench, so that you can pick the values that are allowed for a certain attribute, or that you find the description directly in the Workbench. I think I can show it maybe directly in the Workbench. So I have FME 2020 here with the Inspire Solution Pack already installed. If you are a FME user, you directly see that there's a bigger number of transformers than usual. And if you explore the transformer categories, you will see that there's categories for all the Inspire Annex themes. And it is divided between Inspire GML and Geodatabase. This has the reason that we support writing the Inspire GML as well as the ArcGIS for Inspire Geodatabase that Esri provides that you use when you provide your services using ArcGIS for Inspire. But I think the transformers are only one part of the whole product. I think probably the most useful part of the Inspire solution pack is the templates. So if you go to the templates that are installed in your FME, you can also find templates for all the Annex themes. And these templates basically provide a starting point for your data integration project. So for instance, if I want to map earthquakes data to Inspire, this belongs to natural risk zones. I just pick the template and then you will find a predefined workspace where you already have some of the things that you will need to map your data there. So you find the target model already in the workbench. You have some of the transformers that I've been speaking about there. So there's a transformer to create the identifier. There's transformers for the lifespan. And then, for instance, here's a code list for the hazard category where you can pick which kind of hazard you are mapping for Inspire. And then you basically have to put in your own source data and finalize the mapping. I have a small workspace where I mapped some earthquakes data from Germany to Inspire. So here you can see that I basically connected it to the right target feature type. In this case, it's observed events because it is earthquakes that already happened. And then I basically went through all the red gear wheels here to find transformers where I had to provide some information. So I put in the namespace, I selected which one should be my identifier. I selected earthquake as a type of hazard and so on. And then I just needed to put in some extra feature attributes that are not part of the predefined mapping. So there's, for instance, the name of the event, which I take from an input attribute, and also the intensity. Yeah, and with that, I'm already done and have a ready Inspire mapping. So I can run this workspace and see if I get valid GML. I turned the validation on. And as you can see, the validation against the schema in this case, not against the ETF validator, didn't find any errors. So this is, I mean, this is now a very simple example, but this is how fast you can map data if you just use the predefined fields and then go through the mapping. So let me just go back to the slides. So when you look at the templates, you can see that there's usually a pre-configured part and an individual part. Of course, it depends on how complex the data theme is that you have to provide and how complex the target schema and your source data is. So the individual part might be much bigger. But in the case that I just presented, there's also cases where it's fairly simple. All of the templates that are available are also available from the FME hub, so that if there are updates to templates or if there's new templates, you can always go to the hub and download these templates directly and benefit from the new templates. There's also a template that allows you to create atom feeds. I think most people are probably familiar with atom feeds. Atom feeds are an XML-based format that is normally used to share and distribute information on the web, mainly on websites. But around Inspire, it's also used as an alternative way to fulfill the requirements of the Inspire data download service. So you basically link to your data sets from an atom feed and also link to the metadata and so on. And then you just put it on a web service, and it's quite an simple and straightforward way to provide data for Inspire. Inspire, there's probably 3 different types of validation that are important. So the basic one is probably the schema, the validation against the application schema. Then you can have more in-depth checks if you check geometry and attribute values, and also the business rules. So that's what with business rules, I mean something like the ETF validator. So so the second type, first type was the schema validation that you basically do when you run a workspace and you have the validation switch on the writer. The second type of validation is more about the contents of the data. This is only covered by the schema validation to a small extent, because the schema validation does not check the semantics beyond the structure. So there are, of course, a few exemptions, but in most cases, it will not warn you about corrupt geometries, or if by accident you put the address number in the street name, and vice versa. So FME has some very powerful transformers that allow you to check all of these properties. And with the attribute validator, you can basically check for all kinds of things, attribute values, encoding, ranges, and so on and so on. And then you have the geometry validator, which allows you to find almost any issues your geometry could have. I think the most common ones are probably things like self-intersections or issues with orientation, but there are many more tests that you can select and make sure. And it's the one very important property is that it's also possible to automatically fix the issues that are found, at least in some cases, of course. Not everything is automatically fixable. Yeah, and then the last category of test I would like to talk about is against the business rules. So everybody knows the ETF validator. There's a transformer in the FME hub that you can use to run tests against the ETF validator directly from FME. And basically, when you run a test against the ETF validator, you get back a test report that looks usually like either like on the left side or on the right side. Normally, you don't want to appear anything red, because that means that you failed some of the tests. And one really nice thing about FME is that it not only allows you to find the errors, but it's also possible to fix the errors. So here's one example where we were checking administrative units, and there were some overlaps between the areas at the same level, and also some of the boundaries didn't match the topological structure of the areas. So we used FME to fix this problem. In this case, it was really easy. Just use the snapper to fix some small overlaps in the borders. I mean, the image that I put in here is more a construction, because the errors were really tiny in the sub-millimeters, so that I couldn't even really display it properly on the screen. Just to give you an impression what FME did here. So to sum this up, I think it's obvious that FME provides a great number of functions to do all kinds of validation. This can be geometry, schema, attributes, or business rules like ETF. But I think the most important point, and probably one of the biggest advantages of FME, is that it cannot only detect these errors, but that it also gives you the tools to fix almost any of the problems you might discover. And I think that's really the biggest advantage, if you have a tool that it's not only able to find these errors, but also helps you to fix them. I think at this point I will hand it back to Dean, who's going to talk about connecting web services and APIs.
All right, thanks a lot, Soren. Are you able to see my screen now? Let me switch back. Hopefully that's visible. Okay, thanks for covering the Inspire solution pack from Conterra and also giving us a good overview of validation. And yeah, we could see from the poll that validation is certainly a key aspect of what people are interested in today. I'm gonna zip through the next few slides fairly quickly, but this deck will be available later, and most of these sections have links for more information. So if we don't have time to get to everything, you can certainly review this later. So right now I'm going to jump into just a really quick overview of one project that Conterra has been involved in for the last few years. And the topic here is integrating, sorry, just to jump back, connecting to web services and APIs, and that's really the theme of today's workshop. And so this is a really good example of integrating base map data with real-time air quality information from across Germany. So the main goal of this project was make air quality data available to the public, allow for early detection of risk, view monitoring stations from across Germany, and provide not just view the data, but be able to download that air quality data in different formats. Behind all of this was the need for improving the automation and also demonstrating the use of OGC's sensor observation service in the context of Inspire. So there's a range of the air pollution measurements that are taken and types, and those are the directives supported by this. And UBA, I guess that's the German abbreviation for the German Environment Agency. So in terms of the components that go into this, there's an existing system based on ArcGIS, FME, Map Apps, and SQL database, and that was extended by the SOS server from 52 North, Postgres database, and the Map Apps ETL. You can see here from the architecture diagram the SOS database and which FME is used to load. And there are also FME workspaces which generate Inspire GML for an Atom feed, as Soren mentioned earlier, an example of that. And FME is used to load the Esri geodatabase, which is used, I think, probably ArcGIS for Inspire to provide view services. So that's the basic process workflow. FME is used to load the SOS Sensor Observation Service database, which can then provide those services to clients that way. And then FME provides the data download feed as well. So this is an example of some of the data coming in, the observations and measurements, GML, and that includes things like time period, air pollutant, station, measured values. So that runs every hour, and there's more than 100 measurements across every German federal state. So the states are the ones actually providing the data. It consumes both the metadata and the air quality data, values for each pollutant, and writes that into the sensor observation service database. And under the hood, there's a lot going on in terms of data harmonization between Inspire, the SOS service, and database itself, and as well as quality assurance. And then for data download, looking at that from the client side, and again, sort of supporting this idea of web services to thin clients. So Map Apps provides the control parameters for the request, and that is used to extract data from the SOS database, filter out what's required, reproject it, and then write it out based on the format that the user selected on the web form, and send them a notification email when it's ready. So there's just a quick snapshot of what that looks like. So that's basically the web form. There's a link at the bottom there. I don't know if Trent, you might want to paste that into the chat, and that'll be available in the deck later. But the results were easy public access to the data, helping establish OGC's sensor observation service as a really good example of that, supporting air quality data for Germany, and ultimately also improving data integration and automation for the EDA SDI. So I wanted to give you one example. We don't have, there's a lot more examples available, but I just wanted to give you a practical implementation example of how we can leverage Inspire data to provide services to the public. And so the basic pattern there, reading Inspire data, combining that with either in-house or real-time data, and then a lot of these API interactions, you can use FME HTTP caller. That's the name of the transformer we use for interacting with things like REST services, and then we can do things like mashup and make data streams available to web clients and mobile clients. So just a few words on enhancements before we jump into the workshop. So there's a lot more information available on our website on FME 2020, but I just wanted to highlight a few key points that are relevant for Inspire. One of the big ones is the new application schema-based XML reader writer. So we have an existing XML reader writer, which does a fairly good job of consuming XML, but writing out the XML, you have to use a templater and you have to have a fairly deep knowledge of the XML structure you want to write to. Now for GML, for almost a decade now, initially, early days, we had to use templates. Some of FME old timers might remember using templates to write the GML. And when we added support for Inspire was a big part of this. Adding support for application schema meant you could, as soon as you had a new app schema, you could just import that directly into the workspace and write to it. And so we now have that support for XML. And so ISO 19115 metadata, you can basically drag and drop those schemas into a workspace and write to them. So we think that's a big deal, and we're going to see new readers and writers and tools that come from that. And one other thing that we added recently was geometry by reference for GML and CityGML. And we continue to do bug fixes and improve performance and do enhancements for our overall GML support. And you'll see we keep adding support for new formats from OGC. And there's also CityJSON, which was added in 2020, and CityGML version 3, which we have some partial support. We'll have full support soon. And we added WCS and MTS, and the OpenAPI stuff is coming soon as well. Just a quick mention on 3D, and we can maybe get into this a little more in the Q&A if people are interested. I just wanted to mention that while 3D isn't the first thing you think of when talking about Inspire, I think it is pretty important when you get into the Annex 3, for example, geology, buildings, and often when you're talking about overall SDI, you do need your infrastructure to handle the third dimension. So I think we've invested a lot in our 3D support. There's been an emphasis more lately on GeoBIM, indoor, so whether that's CityGML or IFC or indoor GML. So I think, and our texture support as well. So having that as part of your infrastructure is certainly helpful if you're doing anything. So the big emphasis we have now is really about FME for the enterprise. We're not really focusing exclusively on the GIS department anymore. It's about how can you free your data across the enterprise. And so the Inspire data itself, how that can be integrated with data from different departments. So we're not stuck in one silo per department, but bridging across different applications and systems. And the key for this is FME Server. Because with FME Server, everybody doesn't have to be an FME expert. You can publish a web space, and you can see on the left side here, every published parameter in the workspace just becomes another field on the web form, and that can be made available to anybody in the organization or even on the web. We'll see in a minute with our example. So that can be on-premise or in the cloud, and essentially take a data transformation model, and you can use that to do scheduling, provide upload or download services, streaming services via REST, and notifications. So really the sky's the limit there. And the main thing I wanted to highlight about 2020 is the automations infrastructure. So really this is our way of providing event-driven workflows. We've had this for quite some time. We called it notifications, and really the enhancement here is building a GUI so that you don't have to use a whiteboard to figure out which event triggers what, but you can actually visually author that the way we do on desktop for workspaces. So the whole idea here is workspace orchestration. So we have events in the green box here. That can be a schedule, it could be an incoming email, and we can use workspaces to filter those events or do the processing required. So in this case, maybe, for large jobs that maybe has a different process flow than small jobs. And in the end, publishing that result somewhere, maybe uploading something to S3. So essentially, automations give you event-driven integration capabilities to the FME platform and allows you to orchestrate your workspaces in terms of parallelism. So you can. It also changes your basic approach to workspaces, and some advanced users may have seen workspaces with hundreds of transformers, and you don't really need to do that anymore. You can break that down into more focused things that can run in series or in parallel. It kind of changes your approach. And there's a lot more information we can get into, but don't have too much more time. So I'll just mention briefly other FME server enhancements that are related to automation that can support your Inspire workflows. FME Server Apps allow you to deploy web applications, and that's one we are certainly doing for this exercise. And that lets you publish a URL with a token so that people can run a workspace without having to log into your FME server. And you can also provide web hooks for web apps and embed the parameters in those. And I'll also just mention quickly FME Express, which is our mobile app that runs on iOS and Android. And it does exactly the same thing as a web client would in terms of calling a workspace or an FME server job. So you can do that from a mobile device. And Soren mentioned FME Hub. That's a fairly important way that we can deploy web connections and custom transformers in a way that you don't have to upgrade FME. As long as you're in the main release year, you can use that stuff. So this is just a view of FME Server Apps with a map control that allows the client to digitize a polygon, let's say, for an area that they want to download data for. So just a quick Q&A. Trent, I don't know if you had any questions yet. That we covered a fair bit of ground, and they're sort of at the past the halfway point here in our talk. And so, yeah, if we have any questions, not sure.
Yeah, no.
So far, or in the chat, nothing.
Nope.
Okay, that's fine. We can. We'll probably get a few more questions as we get to the actual exercise. So, and certainly make note of any questions you have towards the end. We'll make sure we have a good 10 minutes or so for discussion. Keep going. If anything really pressing comes up, feel free to interrupt me. So now we'll jump right into the exercise, the flood notification assistant. And those are the 3 exercises that we're going to run through: data extraction and loading, integrating of the real-time flood warning REST service, and then generating impact map reports from that. So this was we participated, both us and along with Conterra, we had a team that participated in the data challenge in Helsinki. And so this was the main project we did for that. I believe we got second place for that. So That was a lot of fun to work on. It was a fairly tight timeline. And the whole goal of this, the flood warning assistant, is to address the increasing climate change impacts that we're seeing. So it's not just that storms are getting larger, but there's a combination of climate change impacts. Let's say if you live near the seaside, you're dealing with both rising water levels and larger storm events. So you can have a sort of cascade or combination of natural hazards to deal with. And so I believe that this is really one of the core reasons why Inspire was envisioned, was the ability to manage our natural environment and respond to it appropriately and provide information on that to the public. And also ultimately to feed back that information so that we can build systems that are more resilient and live in a way that's more resilient to changes in the environment. So in this particular case, what we want to do is leverage the Inspire base map data that's available and combine that with real-time information. Obviously, Inspire data typically, I mean, we've got the SOS feeds, for example, but a lot of Inspire data that's out there is really good as base map, but it helps to enrich that with real-time data. And the other key aspect is to make this easily accessible to the public. So while Inspire Gmail is a great data model for modeling complex data, it's not that easy to consume. So there's what the architecture looks like. We start off, as I said, with the Inspire base map data coming from the GML, and there's also a open API feature service that we read for the National Land Survey of Finland. Then we combine that with the real-time flood warning data, which comes in GeoJSON, and then there's an FME process that extracts and loads that into the staging database, which is hosted in GeoPackage. OGC GeoPackage, those are the names of the tables. Then we have the flood and impact REST service, which is behind that web page. Users interact with that, and as they make requests, the data is extracted and HTML maps and reports are produced. So that's the basic workflow. Just a bit more detail, and we'll get into these workspaces so I don't have to read through this. So yeah, this is the basic workflow. You select an area of interest. Again, I'll remind you, if you're playing with this in parallel, please don't increase that size bigger than about 20 or so kilometers, because if it gets too big, then it'll dim the lights on the server. Overall, if when we're not presenting, go ahead and put any query you want. Things will eventually restart, but for now, if you can limit the size of your queries, that might be helpful. So we select the area of interest, the warning, the flood warning type and time, and we can choose whether to display flood warnings or associated impacts. So I'll just run through that quickly again. We'll see if we have any data for, we had some data here yesterday for London. I'll see if it's still there. Yeah, so what this is this is a tidal flood on the Thames. And so presumably the water levels are higher than usual, and so there's flood risk along this area. That's just west of London. You can say pretty close to Heathrow there if you're flying through there. Not too much flying going on right now, I guess. So that's, if you say impact to none, it generates flood warnings, and I can do that, say, for the Birmingham area. I'll uncheck. I modified this since last year, so we could just focus on the year 2000 data, so you can see some flood areas around Birmingham. And then what I can do is, if I set the impact type to roads, for example, then I can run the same report and find out which roads are impacted or other infrastructure. So you can, feel free to play with this at a later date. This is always up on the FME Server Playground. And the flood data comes from the UK Environment Agency and, as I said, the National Land Survey of Finland. So this should give us a report of infrastructure that might be threatened by the floods. You can see there's a school right next to this river, which might be affected by a flood in that area. So that's essentially it. That's the application from the user side. And now next we'll go through some of the workspaces used to support that. Okay, so now this is just going back. We showed the slide just before we started, but any of you who may have joined after the top of the hour, this link is in the chat. So if you want to go ahead and start that up and run it, basically you go to this link and you have to provide an email address, and it will send you, the username is going to be administrator, the password's in the email. And there's a few tricks there. Feel free to send a message to Trent if you have any trouble getting this going. And you can either do that via the WebEx chat or the Slido Q&A. So the main thing to note here is that there may be some workspaces where you have to edit the source path if it might point at 2019 instead of 2020. And you may also, I think most of the source data sets are zipped, so you might need to unzip some of those. I'll go ahead and, oh yeah, and for those of you who want, don't feel too rushed. If you want to work through this after the fact, you can just go to this link here, and that's what the flood warning system tutorial is like. You can download all the data and the workspaces and actually work through that offline afterwards. So don't feel pressured to get through this all today. So I'll just show you very quickly. I'll run the first workspace in this instance. So exercise 1, I'll just quickly run the roads example. And while this is starting up, I'll just mention that if anybody wants to play with FME Server, you can just, in the longer workshop, the one that was a 3-hour one, we had an option for playing around with server. In the interest of time, we don't really have time for that now, but we can certainly give you a server to interact with if you want to play with a mirror or of this particular application. So I'll go ahead and run this. And while it's running, because it takes a little while to churn through the data. This is a typical extract, transform, load workflow. So the first problem is the great thing about the UK Ordnance Survey is they basically have published all their data, all their Inspire data. So they have their particular profile of Inspire, but they have roads and infrastructure data for the whole country. Now, obviously for an application like what we're trying to produce, we don't want every single cow path or every single road. So we're trying to filter this down to just primary routes and trunk roads. So that's what this tester does. Then we want to build a road name. So some fields are populated and some are not. So we concatenate that together to build a composite road name. And then early on, I figured out that there's a lot of very small road edges. And so we group by road name. That's what the aggregator is doing. So it reduces, again, the number of roads, simplifies things a bit. So that whole simplification workflow. Removing some of the properties we don't need in our output, like the lists, and then doing some schema mapping. So simplifying some of the field names. In particular, we're writing to GeoPackage, so some of those have to be simplified. Okay, so while that's running, I think what I'll do in the interest of time is just look at the previous result, and then we can always come back to this. So data inspector, so Workbench is the tool for running the workspaces. Data inspector is the tool for actually looking at the data. Oh, it looks like it finished already, so we can go ahead and look at today's output. The DB backup, because you're overwriting, we've provided you backup copies of the data. So in case you make a mistake and overwrite your data, because some of the subsequent workspaces depend on data from previous. So if you overwrite your data, it's good to have a backup. So there's just an example of some of the roads data that's being extracted, so essentially converting from Inspire and loading that into the ODC geo package. And you can see we've simplified the road name and the road type, road classification. So that's pretty much all the time we have for exercise 1. Just wanted to show you a quick example of that. And for exercise 2, we look at, well, there's one other one I was going to show you for exercise 1. So I have the WFS 3 reader for the National Land Survey of Finland. And this one I like because it shows how you can consume data from a variety of sources. So I know we're about to add a new WFS3 reader, so these first 2 boxes would just get replaced by a reader. But the reason why I'm showing this is because I think it's a great example of how FME can interact with live data streams using HTTP caller. So basically what you do is you build the layer request, and then the HTTP caller sends that off to the WFS3 server to get a list of layers. Then we have to parse that here and pull out the GET request, and then read that. So the GET feature request, and the GET feature request basically just returns GeoJSON. So I'll just go ahead and run that. So this is interacting with the WFS3 server that's constantly updated, so it has both historical and current flood information. If I look at the output data from this, you can see that this was just generated now. You can see the GeoJSON that's created from that. And then we can always open that up in the inspector. And so you can see this has some fairly recent data. Zoom in here to this lake. Some historical, and then stuff from 2020 as well. So that's the WFS, and that gets fed into the same flood database. So that's exercise 1. Okay. So exercise 2 is the UK Environment Agency's flood warning. So integrating that REST service. So this is where we're layering on the real-time data. And I wanted to, I'll just run that quick, and then we'll explain what's going on with that. So this should get us the flood data that we saw, because it's hitting the same service. And I think I have this all bookmarked. So if I go back to the presentation, we just saw the WFS3. So here, oh, yeah, I should have saved it. So it looks like there is one flood. Okay, so this is the URL to get the flood warnings. And then in order to get the polygon, this doesn't actually embed the geometry. We have to open up a new tab and paste that in. So what we want to do is automate this. So that TEMS has been downgraded to a warning. Sometimes for us in the middle of summer, there's no floods, then the demo's not as interesting. But so that's basically the GeoJSON that gets returned from this polygon. So what we want to do in FME is read the flood warning and then extract that data from the polygon and then build that up, load that into the database as well. So the first feature reader here, I'm not going to go through this whole workspace, but the first feature reader gets the flood warning, and then we parse that and pull out that polygon link and use that to get the GeoJSON. And then the other trick here is the geometry replacer. We take the GeoJSON, so instead of encoding, we decode that and instantiate the polygon, and then combine that with the attribute information and write that into the database. So we'll just look at the output of that. So that's a current flood information for the UK in this case. And there you can see that that's the same polygon that we saw when we did the web demo. So that's the Thames tidal flood. And then the last workspace I wanted to show you is the actual, so all of these workspaces were just meant to load the database, both the base map information coming from Inspire, real-time data coming from the REST service, and now we want to generate reports and basically feed information to the web client, interact with web client. So I'll go ahead and run that workspace. That's under exercise 3. Just a note that when you're running FME, and if you want to publish to FME Server, one of the reasons why it's a bit tricky with the instance you have is that the FME Server right now I'm running is 2019, but the default training instance is 2020. So you have to publish to the same version or newer than what you have on desktop. So just a little footnote about that. But we can certainly provide support as needed. So that's the flood warning. No, if you want flood maps, that's the last one. And again, if I'm going a bit quick, all of this is explained in the tutorial. Work through it at a more relaxed pace. So in this case, we're just going to try running, set this to none. You'll see that these parameters are exactly the same parameters that we'll see on FME Server. I'll show that in a second. And also what you see on the web form. So that's how everything is tied together. And so this is getting past flood information, querying the OGC geo package, and then generating a flood report, HTML flood report. So I will go to that file that was just generated. And so those, the XY locations, it just looks like past floods at that particular location. So I didn't change the lat long. It's not, this is not London. This is a little, just a bit north of Birmingham. So that's running that workspace to generate a flood report. And then if we want to see, well, what infrastructure does that flood impact? Then we change the impact from none to infrastructure and rerun the same report. So that will overwrite it. And then we get a sec here. That wasn't quite finished. I jumped again. So it figures out which report we're looking for and feeds now it invokes this particular report generator. And so I go there now. You can see the infrastructure that might be affected by floods in those locations. So various schools or hospitals that might be affected by floods in those areas. Yeah, St. George's Hospital there. Yeah, so that's basically the tutorial in a nutshell. Let me just highlight a couple of points here. The spatial filter is key. So that's one key aspect of this. This basically takes the flood information with a small geographic buffer and sees which infrastructure or roads features intersect with that flood and feeds that into the report. Yeah, we're doing some filtering here. We don't care about all infrastructure, so we filter it down to areas of interest. And let me just show you briefly the HTML report generator. That's really one of the key tools for publishing. So here's where we build up the tables and the leaflet map. So it's really quite a powerful tool to quickly, I mean, you might want to have more refined tables and there's lots of other ways of generating web content, but to quickly prototype something, HTML reporter is actually very useful. And that this uses our HTML writer. So I think that's pretty much all the time I have. I did want to quickly, we've got 25 minutes left. I wanted to quickly just show what that looks like on server. Find the server here. So this is the same server, the data challenge repository. And so if I was going to run, let's say the flood map, you can see the same parameters here. And, you know, so if I choose infrastructure and run that, it's a data streaming service. So I'd expect to see a similar report come back. So that's what it looks like to run it from FME Server. And we can certainly answer some questions about server during the Q&A. So pretty much all the, don't have too much time to dig into it, but there's the same report. And actually the one thing I did want to point out about server, which is kind of cool, is that I did mention in the presentation the webhooks. So in the advanced mode here, you can create a server app or a webhook that will run that workspace. And so this is the URL, I think, that will run that exact workspace. I think I can copy it here. And so then if I paste that into the browser, I guess didn't do the right authorization. Anyway, that's basically the approach. You can take that URL and paste it into a browser. I won't fiddle with it too much right now. So just a few quick lessons learned, and then we'll get to some Q&A. We think it's really important to make sure you support domain expert and stakeholder collaboration. And I think that's one of the benefits of a data model approach rather than, let's say, coding everything in Python or something, is that it allows you to leverage those experts who really know the data well, and they can focus on what they know, have them collaborate with people who know Inspire really well. And so getting that team to collaborate is pretty important. Also, having systems that both produce and consume Inspire data is key. That way you can constantly test your output and say, okay, does this make sense? Is it georeferenced correctly? Find there's always this trade-off between flexibility and usability. Even something as simple as this flood impact dashboard that we built here. Obviously, to make it usable, we have to filter out a lot of the Inspire data in the background and just focus on what we need. So there's always going to be that trade-off. And so knowing your user community is very important. And I think the enterprise perspective is really key. So don't just think about which Inspire problem you're solving today, but build infrastructure that is that's capable enough, rich enough to serve a variety of use cases. So for example, if you're going to provide Inspire download, allow people to choose which format. Maybe they want Inspire Gmail, maybe they want a PDF or a shapefile. So, you know, don't just make Inspire in a silo, but have it support the overall SDI. And being able to do rapid prototyping means we can pick some of the easy wins early and show some early success and get buy-in for projects. And the other thing we've seen over time that's really key is automation, making sure systems are easy to update and are future-proof, capable of things like alternate encoding support. So some of the key takeaways, FME does simplify your efforts around Inspire compliance because you don't have to do any coding. You can just develop these visual workflows. We support the data extraction and transformation required to populate Inspire data sets and validate them. And FME Server makes it a lot easier to share Inspire data and services. And we also provide a lot of tools that make it easy to leverage the Inspire infrastructure that's out there and combine it with your in-house data and other real-time data streams. So yeah, we believe that, okay, we're nearing 2021, but that's not the end. It's really just the beginning. So having capabilities to harmonize and consume Inspire data and integrate it, I think we'll see a lot of great new projects built on Inspire as time goes on. So just a nod to some of our partners. I thank Conterra for their support on this presentation, and they have more than 100 Inspire implementations across Europe. And there's a lot of other partners that are very active. So you can go to safe.com/partners and see which partner is in your area, and I'm sure they'd be glad to support you. We have a lot of resources. We offer free online training and tutorials, some of them in person, and some of those are recorded, or you can do live in-person training and get an instance like the one I just showed you today. And people can actually help you through a chat to work through some of those workflows. Just a quick mention on COVID-19, we provided more than 1,000 licenses for those working on COVID response and research. And we've also prioritized COVID-related support. A lot of our partners are active, and we also participated in this hackathon in Canada. It was sort of the Canadian chapter, but I believe it got started in Switzerland. So there's safe.com/COVID-19 for more information. So, and just a few Inspire-specific resources. You can just search EU Inspire tutorial, and I think our tutorial comes up pretty, at least for me, near the top. And we have a lot of other tutorials related to XML, JSON, 3D. The community is very active, so you can search the community for Inspire. You can Google FME Server Playground and get to this demo. And so, yeah, here's some links for more information for the Conterra ISP. If you do want some support for the tutorial, you're welcome to contact us at safe.com/support. Just make sure you put Inspire in the subject line. I think the other option is support@safe.com as an email. So thanks for your time. And yeah, we'll open it up for some questions. I guess we can, Trent, did we have any Q&A there?
Yeah, we do have a couple questions. First one, is there a way to get to send out the slides to everyone?
Yeah, absolutely. That will, I believe, that will be made available on the. I've seen it on the schedule, but
Okay.
so I think the JRC will make that. We give that to the JRC, and they'll publish that on the Inspire website.
Yes, then just to confirm that all the slides and also recording of this session will be available afterwards on the conference webpage.
Right.
Okay. Perfect.
Okay. Any other?
So now some ones that kind of directly relate to the work. So at the start, there was mentions of the SOS API. Has either Contera or yourself, Dean, worked with the Sensor Things API?
Yeah. Oh, so Sensor Things API. Yeah, that's a new OGC standard that is, I believe, more REST-based. So it's along the lines of the Open API approach. It's almost a precursor to Open API. Yeah, we're very active with the OGC, and so I've seen some good demos on Sensor Things. I wouldn't say I have a lot of experience with it yet, but certainly using this type of approach, like some of the examples where we showed you feeding things through HTTP callers, you could certainly use that approach to interact with Sensor Things. So if there is a web service and you need help figuring out how to interact with that, send us a note on support. The other thing I may as well do while you're asking, this might be the place to look if you're looking for a new web connection. Just go to FME Hub and click on Web Connections, and you can see some of the connections that are currently available. So that might be one way we connect to Sensor Things. We might put a Sensor Things example here. So not all connections will necessarily show up first as an FME format. Some of them may be available on the hub. That's a good question.
And then the last one, I think kind of directed with this as well is, do you know, so with the, if using Inspire data with MQTT connections, so getting a stream of MQTT messages?
Yes, yeah, that would be something that you would integrate on server. Tabs open here. And get back to my FME server. So that I think here, like under our notifications framework, I believe there are MQQT protocols. Well, I guess we have SQS.
We do have a connector in like Workbench.
Oh, there is
that
a
was
connector
added.
when you just go in Workbench.
Yeah. And I guess the question was kind of, so if you're doing a stream where it's kind of just a steady stream of messages in and it never actually like fully closes the connection, do you know how that functions on FME server, for example? Like, does that just keep the job running and tie up that engine the entire time? And you would have to kind of plug it into, for example, an automation in terms of when to actually.
Yeah, you might have to set a timeout. So is that they're sort of asking if it can be made asynchronous, or I think if you have a message pipe, and that I know that with FME Server 2020, they've made it a lot easier to have to manage your data streams for permanent, like for constant connections. And so for some of these, you may end up tying up one engine if you want to constantly listen to one data stream. Or you could periodically make that connection and disconnect it.
Gotcha.
But if you have a specific use case, yeah, please follow up afterwards and we can work through that. So that's my contact, Dean@safe. So that's fairly easy. And there's Soren's. Christian, while if you're still available, maybe you could just say one or two words about the current status of that German air quality project. Has there been any updates to that, or?
Yeah, hi everyone. It's Christian from Contera. Yeah, sure, Dean. So this is ongoing. This is always running. Let's say, and so year by year, so we identify also new topics. So what we are currently doing is we adding noise relevant data or noise data to the overall infrastructure. So probably this is important to know this so-called UBA SDI. Let's say it's not only there for the purpose of the air pollution data, but also for other kinds of data where the German Environment Agency is responsible for. So we use the same infrastructure, or basically with the same infrastructure. They're running other topics, of course. So for example, noise is one of the current things we're supporting them with. Yeah, probably that's.
Yeah, very good. And is that, do they run that with FME Server on premise, or do they have anything running in the cloud?
Yeah, it's on premise.
Yeah.
It's FME Server on premise. Yeah, right.
Good. All right. And did you see any other questions there, Trent? I did want to show quickly the data over in Finland, because I know a lot of the demo we spent in UK. Have a look at Helsinki. We look at, let's say, flood data from Helsinki from in 2000. Oh, try that again. It does reset to London every time, unfortunately, so you have to kind of keep panning over there. Yeah, so here you can see some historic floods near Helsinki. So that's the data coming from the WFS3 or the OpenAPI. And there's looks like we have some coastal historic flood zones here. So did anybody have any trouble getting things to run on their, I believe we're running, Trent, do you know offhand, are these EC2 instances or?
Yeah, last time I checked, they were EC2.
Actually, while we just have a minute or two left, I'm gonna just go back to that. I kind of flew through this workspace, the reporting workspace pretty quick. See if there's anything else here that might be useful to know. In terms of updates, I did this workspace I have is a little bit different because I added parameters to support 2020, and so I added some additional logic in here to make sure we can collect, filter and collect floods from 2000 onwards. And here you can see the other thing that's key here. When you publish to server, we use database connections. So that's the other aspect of this that's key. And maybe I'll just show you really quickly on the server here. So these are all the workspaces that have been published. And the other nice thing about that's been fairly new on server is just this ability to manage everything as a project. And so here are all the components that go into the data challenge project. So that, there's all of the workspaces, and the connections. Hang on a sec here. Yeah, so we have a collection of schedules. Some of these schedules run hourly, some of them run every night. So the real-time flood data is brought in every hour, and then we basically move the current flood data to past every night. So that's all done in schedules. Here. Yeah, so you can use a cron expression, or you can just pick it off a list there. And we just basically point the schedule at the workspace that we want to run. And of course, we have training specifically focused on FME Server. Oh yeah, the last thing I'll show you really quick is just the workspace viewer. So we are moving towards being able to look at the workspaces on the web, so you don't necessarily have to open that. You don't have to always download a workspace. Sometimes if you just want to make simple changes, you can do that here on the web. That's something that's still evolving. Okay, well, if there's no other questions, I would really like to thank everyone for their time. Soren, did you have anything else you'd like to highlight in terms of conclusions?
No, not really. Just want to say thank you to everyone else as well.
Yeah, thanks to Vladot and to Karen and all of the staff at JRC for hosting this conference. Thank you all so much for your time. And, you know, it was a little bit rushed through a few of these slides. And so we will definitely make sure we make the whole deck available. And certainly feel free to work through that tutorial at your own pace. And so you can download the workspaces and get the the free licensing. We also offer grant licensing for educational and research purposes. So make sure you avail yourself of that. And yeah, thanks everybody. And yeah, stay in touch and enjoy the rest of the conference.
Thank you. Bye.
Yeah, and yeah, thanks to the Conterra team as well. Thanks to Soren and to Christian for
Bye.
calling in, and support from Trent as well.